Yes, good morning, everybody. Welcome to the first session this morning at the Carbon Farming Workshop. I hope all technical issues are solved and anybody can see and hear what happens. As far as I can see, 82 people are attending this small workshop we have here. We have 3 interesting talks on chances and limits of soil's carbon for climate protection. And we will analyze and give some information on techniques, on capacities of soil and possibilities, how to enrich carbon in soils farmers can take and try to take, and on analytical limits. We have 3 speakers on the panel. It is firstly is our Yumshu Chade. He's a colleague in the Carbon Farming Project, and he give a report on current trials the carbon farming team has established in the different regions of the North Sea region to show what might be limits and chances of carbon farming in practice, and to show up practical limits of analytics as well. Axel Donn is from the Thünen Institute of Climate Issues in Agriculture in Germany, and he's specialist on soil analytics and soil capacity and for carbon. And we have Martin Wiesmeyer from the Bavarian Research Station, who's an expert in soil issues as well, and also is keen to tell you on some limits we have in practical reporting of climate effects by carbon farming. So I will open the floor and ask you, Sauer, to start with your first presentation.
Thank you, Hans-Martin.
Yes, okay, we can see what is on the screen.
So, ladies and gentlemen, my name is and as Hans-Martin mentioned, I'm working also on this carbon farming, and it's flow and
the sound is really bad. Sorry, so to interrupt you.
Yes, the same. Can you change something? It's really broken what you say.
Now, can you hear me better? Okay.
Yeah, the sound is perfect now, but we cannot see your presentation at the moment. Okay, we have it on the screen. Yes, can you try to say something, Sauer? No, that's a problem. So let me try to give you a presentation and maybe you get the sound for it. Yeah. So now we have it, I think. So maybe you can start. Yeah.
Can you hear me?
No, sorry. No, the quality is really bad. Maybe we start with the second presentation. Axel, maybe can you share your screen? Yeah.
Okay, can you stop sharing your screen, Hans-Martin? So can you hear me and see the screen?
Yeah, it's great. Okay, just start. Yeah.
Okay, yeah. Sorry for the technical problems. It's really a challenge this time with the new system. But I'm really glad that I was invited here to give some insight on detection limits of soil organic carbon, which is really crucial if we talk about carbon sequestration as part of carbon farming. So there are 4 criteria if we want to turn soil carbon sequestration into climate mitigation as a carbon farming measure. And these 4 criteria is that carbon sequestration should not lead to leakage. For example, with additional organic fertilizers, it's only leakage and not really carbon sequestration. The second criteria is additionality, so it should be an additional measure that we take to enhance carbon. The carbon need to be stored permanent, so the permanence is the third criteria, and fourth, it should be measurable. And the last criteria is the topic of my presentation. We need to really measure the additional carbon in the soil. And we measured a lot in Germany since we conducted the first German agriculture soil inventory that was finished in 2018. And we collected over 100,000 soil samples in a grid 8 by 8 kilometers that was laid out across Germany. And in the end, we sampled more than 3,000 sites down to 1 meter depth. And we used a combined sampling of profile, a soil profile in the center of our sampling points. And we also conducted soil coring at 8 satellite spots around this core point. And we sampled croplands, grasslands, and permanent crops, which is in particular vineyards in Germany. The variability that we've seen in terms of agriculture soils was enormous, and it was really amazing how different soils can be, and we should really be aware of this diversity if we talk about carbon farming. And this also is reflected in the carbon stocks. So we have some soils storing only 13 tons of carbon per hectare in the first meter. And then we have soils, the organic soils and FEN here with up to 700 tons of carbon stored in the first meter. And we have to deal with this diversity. And if we look at the map of Germany and all the points that we sampled, we see that this diversity is not only regional specific, but if we go from one sampling point to the next, we can find very different carbon stocks within a very small distance of 8 kilometers. On the left side, you see the topsoil, and also in the subsoil, we even have a higher heterogeneity and diversity of soil carbon stocks. And if we sum it up, we see that the organic soils store 5 times more carbon than the mineral soils. So we have a huge range of carbon if we have organic soils in our sampling scheme. And in the end, if we only look at the mineral soils, we see that grasslands store roughly 30% more carbon than croplands. Then we ask the question, so with this sampling scheme, which carbon stock change can we detect at different scales, and we start at the German scale. If we use all the 3,000 sampling points, and we can detect with this sampling scheme a change in soil carbon stocks of 1 ton of carbon per hectare. If we look only at the mineral soils, we have less samples, and then we can detect 2 tons carbon stock change. And this is also if we only look at the croplands or the grasslands separately. But as soon as we leave the national scale but go to the field scale, the point scale, then we can only detect changes of more than 20 tons of carbon. And this is because we used 8 soil cores at the sampling at the field scale. And you should keep in mind that a possible carbon stock change within 10 years is 1 to 2 tons of carbon if we do not use external carbon input with organic fertilizers. So if we want to make carbon farming and climate mitigation, this possibility should be ruled out, and because it's only a transfer of carbon from one side to another if we use organic fertilizers like compost or manure. So if we don't do this, we can only change the carbon very slowly, 1 to 2 tons of carbon within 10 years. And this is a challenge for the detection. And we also looked at the point scale, and we tested if we resample one soil profile. So at one point, at the same time, we sampled the profile twice. So we once sampled it, then we cut it 20 centimeters away and we sampled it again. So within 20 centimeters, we found an absolute sampling error of more than 5 tons of carbon in croplands and more than 7 tons in grasslands. These were 8 grasslands and 8 croplands that we investigated, and it's the average error, but we were really amazed. So the same soil profile and only 20 centimeters away, we get carbon stocks that are more than 5 tons different. And we saw this also here. If we look at the distance of sampling, we also did some sampling at this sampling spot around 10-20 meters away, and we saw that the variability starts really at a very small distance. So the variability or the error is not increasing a lot as we expected, but we already have within a few centimeters distance a very high sampling error. And if we go now to the carbon content, we should be, this is an example of the detection limit. So the mean soil carbon content in German croplands is 1.52% organic carbon. If we convert these 1 to 2 tons in a change in carbon content, the achievable increase in carbon content, it's 0.03 percentage points. The lab error is in the same range, and the field variability is much larger. So in the end, we want to detect a change of 1.52%. After 10 years, it will be 1.55% of carbon. And this is really the precision we are aiming at if we really want to go to the field and measure the carbon stock changes in the second digit. Yeah, and the only possibility to cope with this variability and is to take a very high number of samples at each field site. And there are some rough estimates, 15 samples per hectare, and this might even not be enough to detect the small changes in soil carbon stocks. There are other possibilities, and this is good. And we all hope that remote sensing will help. So all the new satellite data And with the satellite data, we can really get good estimates at field to regional to continental scale of the carbon stock, but not about the carbon stock change. And carbon farming is all about carbon stock change. So of course, it's nice to get new maps of soil carbon, but there's no study that I know of where satellite data has been used to detect carbon stock changes. The problem is carbon has a large range. I showed it with organic soils and the mineral soils. We often have plant cover, so the satellites cannot see the soil, but it's all covered with plants. And the changes in carbon stocks are very, very small, as I showed you. And the last possibility, and this is probably the way to go, is to use soil organic carbon models to estimate soil organic carbon stock changes. But these models need to be selected and calibrated for the region where they want to be applied. You cannot take an US-American model and apply it to a field site in the Netherlands without checking it and validating it. And in the end, we need a lot of data, management data for the field site, not only for the year where you measure, but also the history of yield and carbon inputs with fertilizer and different things that need to be estimated as input data for the models. And in the end, the question is whether model-based estimates of carbon stock changes that produce CO2 certificates are maybe similar like measure-based CO2 certificates. If we give the farmer certificates, if he, for example, grow cover crops, that's a measure to sequester carbon. And we incentivize this measure and not the result. It seems that the modeling is something in between result-based CO2 certificates and measure-based certificates. Yeah, with this, I'd like to thank you, and I'm open for questions and discussions. Thank you.
Yeah, thank you, Axel, for this interesting presentation on practical limits of analytics and samplings of in the field. So we have two comments in the chat. One is on the relation of percentage of carbon and soil density and carbon stock. Can you have two more words on this?
Yeah, I mean, what we always need is an equivalent soil mass approach to detect soil carbon stock changes. So we should always refer to the same soil mass, and that means the same soil density if we want to detect changes. This is an old story, and you can read it from Allard and Bettany and different papers. Okay. But this is also a challenge because in agriculture we have a lot of carbon content measurements, but no real bulk density measurements. And moreover, we also need to know the stone content. So this is a challenge.
Yeah, that's right. So it's an additional effort you have to take if you really want to make an exact estimate of the real stock you have in the field. Yeah.
Yeah.
Okay, great. So we try to enter the next speech. So I would say that Sauer will have a next chance to present. Let's check.
Yes, I will try it. I hope you can hear me better now.
We can see and hear what you say.
Perfect. So, once again, my name is Sauer Cemşirzadeh, and I'm working in carbon farming project. And the title of my presentation today is Improving Biomass Flow and Soil Organic Carbon in Arable Farming, Approaches and Results of 2-year Trials in the North Sea Region. So, short about the contents, I will present you some introductions about introduction information about our trials in North Sea region, and briefly I will tell you something about the material and methods, how we do our trials on the field, and about the results. At the end, I will give some summarizing information and make a conclusion. We have several trials.
Can you try to change the slides so we only see the title slide?
I have already changed the slide. I'm on the 3rd slide now.
And now we cannot see. You are in presentation mode.
Okay.
Yes, okay, now. We are on the search right now.
Yeah. So,
great.
No? Can you see the search slide?
Yes, all is fine. You can speak.
Okay, so we have several trials in the whole North Sea region, in the states, Netherlands, Belgium, and Germany. I will today show you the results from the trials in Belgium, in Netherlands, and 2 trials in Germany. We categorize them under the categories land use, external input, and cropping. Under land use, we mean the agroforestry and grassland trials. Under input or external input, we have the trials like with manure, with compost, with champost, with biogas digestate and wood chips. And under the cropping category, we have the trials like with cover crops, with undersun crops, and with tillage. So we analyzed the soil organic carbon measurement with the following, with the elementary analysis with the following, according to the following methods. So we took the soil samples in different soil layers. The ring soil samples we take mainly in 5 to 10 centimeters, but at the beginning and at the end of the experiments, that means in 2019 and in this year, in fall 2021, we took the soil samples also in subsoils from 40 to 45 centimeters. In Germany, we took also the disturbed soil samples in each year, beginning from the fall or spring, fall 2018 or spring 2019. We analyze we make our statistical analysis with the software JMP. So here you can see the results of our experiments with undersun crops. We try to integrate the undersun crops in our treatments with undersun crop removed and undersun crop incorporated. And here you can see the dry matter, the biomass yields in dry matter on our fields. And you can see that on the biological, on the organic farming, also on the conventional farming, we have a significant higher biomass yield than on the reference fields. For example, on this diagram, you can see that we have approximately 700 kilograms more biomass yield than as on the treatment with undersun crop incorporated in comparison to the treatment without undersun crops. So that means we could reach the high amount of biomass that can be incorporate into the soil to increase the soil organic carbon. So here you can see the results from the 2 years in 2019 and 2020 in North Germany at our institute, on the fields of our institute. With the different colors, we describe the different trials. We have the trials with undersun crop, as I mentioned. We have the trials with tillage management and trials with external organic input. So 2 trials. We have 2 trials with undersun crops. One on the field with biological farming, organic farming, and another one in conventional farming. As you can see, in both years, we have no significant differences between the carbon farming treatments to the reference treatments on all in all treatments, on all trials. So here you can see the results in North Germany. On the comparison between the cropland and poplar in the short rotation capacity fields. After 10 years of poplar, you can see that we have a small difference, but the differences is not significant, both in the topsoil and in subsoil. On this page, I want to show you the results from our treatments from our colleagues in Belgium, from the Inagro. They had also 3 trials. The first trial was with cover crops, the second trial was reduced tillage and tillage, and the third trial was addition of wood chips. On the first trial with cover crops removed or cover crop incorporated, you can see that on both years they had no significant differences. But on the treatment with reduced tillage, after 1 year, they had already the first results. And the treatment with reduced tillage had a significantly higher organic carbon than the treatment with tillage. The same also with the treatment with wood chips. They added 28 tons per hectare trumples in 2019, and you can see the results after 1 year that the treatment with wood chips has a higher soil organic carbon. But I have to mention that we added in Germany only 5 tons per hectare wood chips, and we had no significant differences. But they added 28 tons per hectare, and they had after 1 year we could measure the first significant differences. And on this page, I want to show you the result from the Netherlands, from our partners in Bionext. They had also 2 trials. The first trial also with wood chips, and the second trial, the treatment with solid manure in comparison to the treatment with only green manure. You can see here that in 2020 they had also the first results. They added 30 tons per hectare compost, and after 1 year in 2020, there's a significantly higher soil organic carbon on the treatment with compost in comparison to the reference field. The same we can see also on the treatment with solid manure in comparison only green manure. So they added in 2 years 40 tons per hectare solid manure, and in 2020 there is a significant higher soil organic carbon also. So what can we say in summary? In Germany, we don't have any significant differences in our treatments, and also on the fields with cropland and poplar, after 10 years, there is no significant differences. As the poplar fields do not have a higher soil organic carbon. So, but we can say in Belgium, there was significantly higher soil organic carbon in the treatments with reduced tillage in wood chips in comparison to controls tillage and wood chips respectively. And also in the Netherlands, they have significantly higher soil organic carbon in the treatments with compost and solid manure in comparison with the reference soils. So the conclusion is that in Germany, we don't added much as a high amount of external soil organic, external biomass to the soil, so we don't have significant differences. But in case of in Belgium and Netherlands, where they added 30 or 40 tons per hectare external biomass, we measured a significantly higher soil organic carbon in this case. So now I'm at the end of my presentation. Thank you for your attention, and I will be glad to answer your questions.
Yes, thank you, Sauer, for this quick round through the first results we have from the 2 years trials in the carbon farming project. So we all know that 2 years is not very long for these to gain results from trials like this. Yes. And we also have to check additionality of all these measures. So we have one question, which is directing the Inagro trial on tillage. The question is are the analytics based on equivalent soil mass or on equivalent soil volume?
It's based on the equivalent soil mass. We wanted to check if there will be a difference between the different treatments with and without tillage, or with tillage and with reduced tillage. That's why the results based on the equivalent mass.
Yeah, okay, thank you. And then there are 2 questions on the duration of the trials. So I can answer the first one. We have a 3rd year under analytics as well at the moment to finish the project. It ends this year or next year. So we will have 3-year trials then at the end and results. So we can add something. And another comment is taking it into account the time of turnover of fresh carbon sources. 2 year might be too small to have effects of cover crops. What would you say to this, Sauer? If you compare, let's say, the cover crops with the organic input, do you see fundamental differences or fundamental things we have to discuss when looking at climate change and climate change mitigation by these measures.
Yes, of course. As Axel Don mentioned above, there is a fundamental differences because with the external biomass, there will be no net climate effect if we add the high amount of external biomass. But if we have our own biomass from our field, and we can add this on our fields, there is a chance for the net carbon climate difference. But in the case of the cover crops, it's better, I think, because we integrate the cover crops on the same fields, and here we can fix extra carbon dioxide from the atmosphere and bind it on the soil and in the root biomass. That's why I think the treatments, the measures with the undersun crop is the better option on this case for the carbon farming.
Yes, okay, thank you. Great, thank you for your answers and the comments from the audience.
You're welcome.
Let's go ahead. Martin, can you try to enter the screen?
Yeah, I will try. Okay. I have to try again. Okay. Can you see the slides?
Yes, yes.
Okay.
You're in full screen mode and we can hear you.
So in my presentation, I will give an overview over the opportunities, but specifically on the challenges of carbon farming and carbon credits. Carbon farming is in the spotlight. You all know that. This is really, I guess, mainly an outcome of the 4 per mil initiative, which was presented in 2015. And I think this changed a lot. Yeah? So, and this is really great to see. Also, as a soil scientist, I think we all complained about that we are not really visible at soil science, and the importance of soil carbon is not really visible. And this changed a lot. And and carbon farming is really a hot topic now. You see that here, and you also know that the European Commission prepares a carbon farming initiative, and next week they announced to present their plans on carbon farming. In Germany, we have, also in German-speaking countries, we have a long tradition of carbon farming and carbon credits. So the first one who offered carbon credits was the Ökoregion Kaindorf in Austria. So they already offered carbon credits in 2007. And this is a picture of the last meeting of the Ökoregion Kaindorf. And you see the farmers, they can earn a lot of money with carbon credits. So this is already done in this region in Austria. In Germany, we also have many initiatives, companies, startups that want to offer carbon credits. And an example here is the company Carbozert, which is really active in southern Germany. And as an example, at the last Oktoberfest in 2019, I guess, before Corona, the well-known brewery in Munich compensated the CO2 emissions of their beer production with soil carbon credits. And they advertised that as climate-friendly Oktoberfest beer. So this is already done. So the question is, can carbon credits really foster soil carbon sequestration? What are the challenges of these carbon credits, carbon farming initiatives? And we analyzed that, and we found different challenges which are related with carbon credits. There are methodological challenges, which are already were partly explained by Axel, but there are more challenges with regard to fairness, additionality, leakage effects, greenhouse gas emissions, and permanence. and then we'll give a short overview over all these challenges. First of all, there are methodological challenges. Axel already explained that. So with regard to sampling, so many carbon crediting companies and initiatives, their business models are still based on taking soil samples and determination of the soil carbon changes. And with regard to the sampling, there are a few challenges. With regard to that the sampling must be representative, that the resampling should be done on the same locations as the initial sampling. The sampling depth should be more or less the tillage depth, and the sampling should be done before any tillage or any fertilization in early spring. And these are issues which are really, this is not the problem. So the companies are really handle that in a good way. The problem is the determination of soil carbon stock changes. This is the problem. You have to calculate carbon stocks, and for that, you have to determine not only the soil organic carbon contents, but also the bulk density. Axel already mentioned that. And this is not really done by most companies and initiatives. So they often apply pedo transfer functions or simply estimate the bulk density, but this is not precise enough. So this introduces really a bias. Further shortcomings or challenges are related to fairness, additionality, and greenhouse gas emissions. So fairness, what does fairness mean? So there are no rewards for farmers with already high carbon stocks. This is, of course, a problem. So just imagine an organic farmer or any other farmer who took care of their soils for many years, and they achieved a high carbon level in their soils, but they cannot benefit from these credits. Additionality is another issue. So what does additionality mean? Only management practices for carbon sequestration that contribute to climate mitigation that are fully motivated by carbon credits. So you have to do additional things in terms of these carbon credits to contribute to climate change mitigation. So this also means that there are no rewards for management practices that are mandatory, for example, by the new conditionality regulations of the new CAP. So this is an important aspect. With regard to greenhouse gas emissions, if you have high carbon level in your soil, this may cause N2O emissions. So this is the problem. So a full greenhouse gas assessment is required. It's not only about soil carbon. The most important challenges from my perspective are leakage effects and permanence. Leakage effects, for example, is when you apply external carbon sources like compost. This does not necessarily contribute to climate protection. This is only a relocation of carbon in the landscape. You can see this picture here. So just imagine you have a farmer, and before he or she take part in such an crediting issue, they apply the organic fertilizers homogeneously to their fields. When you take part in a carbon credit program, this would probably lead to that organic fertilizers are mainly applied to a specific field. And of course, you can then increase the soil carbon level in the soil, but this is only a relocation of carbon in the landscape and no contribution to climate mitigation. Another issue is permanence. So an increase of soil carbon as climate protection measure is only effective if the carbon storage is permanent. This is really an important point, and from my view, really the most tricky one. Yeah? So how can you secure that the soil carbon that you build up in your soil stays in the soil? And this is a huge problem, and this is particularly a problem also with in face of climate change. So there are many projections now for the development of soil carbon stocks in temperate cropland soils. And these projections indicate that we will face soil carbon losses in the next decades. So we did a study for Bavaria where we modeled the future development of soil organic carbon for several locations, for several croplands and several grasslands. And we did that for different scenarios in terms of the carbon input. So we assumed the constant carbon input, but also an increased carbon input and 20% less carbon input. And the same or a similar study was done by the Thünen Institute for Germany, and they did that for different climate change scenarios. The result was really similar. So in both studies, we see, or the models projected in the long term, a decrease of soil carbon stocks. And in both studies, we calculated the carbon input needed to maintain our present carbon stocks. And the results showed that we have to increase the carbon input by at least 30, partly up to 90% in Bavaria or in Germany, only to maintain the present carbon stocks. And this, of course, has major implications for carbon farming and also for carbon credits. In another study, we estimated the potential of cover crops for increasing soil carbon. So, and the result of this study was that cover cropping could increase from 10 to 30% in Germany. So there is really a huge potential to increase cover cropping in Germany, and this would sequester 0.6 to 0.7 megatons of carbon per year. But, and this is the important point now, this would only reduce the projected soil carbon losses. So even if we use all the available cultivation windows for cover crops, and we really could sequester carbon, but this would only reduce the projected losses. And this is, of course, a problem because you cannot sell carbon credits with that. This is the problem. So in summary, carbon credits, of course, can stimulate soil carbon sequestration. And what I think it's really important also for the farmers is that they promote the social perception of carbon credits as a contribution of the agricultural sector to climate protection. This is, I think, the main opportunity. However, we also see that minimum standards that are required for carbon credits are not met so far. So we have methodological requirements. We have to avoid leakage effects. We have additionality and also permanence issues, which are really problematic. Our projections of the future changes of soil carbon stocks indicate that we will face soil carbon losses due to climate change. So we have to implement measures to increase soil organic carbon only to maintain the current SOC level. We have to improve the management of our soils and increase carbon input only to maintain the present soil carbon level. So there's, from my perspective, in the future, there will be a focus on rather soil carbon preservation and not really increasing soil organic carbon in the soils. And finally, I think we need alternative funding measures that are not only take into account the soil carbon-based climate mitigation potential, but that also take into account the contributions to climate adaptation. I think this is really needed in the future. Thank you for your attention, and I hope there's still time for questions. Thank you.
Yes, Martin, many thanks for this clear presentation. So let's say what you presented is a major drawback for carbon farming initiatives who are only focusing on selling additional carbon and climate effects. So it's more than that, and I'm glad that you are so clear with all these problems. So we have some questions in the chat. Yes, one is over the natural carbon losses in soils over the next decades. I think you presented what the answer already. So it will be heavy. The scenarios are saying that this soil carbon loss will be there, and it will be hard to let's say, react for farmers to keep at least this level. That's what you said, and I think I see Axel agreeing. So it's hard work to keep this standard and the situation we have at the moment. So
I just want to add.
Yes,
I just want to add something. So these are projections, yeah. And from my point of view, it's important to make clear that we cannot expect that that every improvement in terms of soil management will automatically lead to carbon sequestration. This is the point I want to make.
Yes, okay, great. So if you have a look at the chances we have, if you imagine, let's say, a closed farm with fixed system boundaries, would you see any chances for this farm to increase and keep the soil carbon levels and also contribute to climate change mitigation by this?
So we know from in Bavaria we have permanent soil observation sites, and we are analyzing the soil carbon development in the last 30 years. We have 80 sites, and there are sites that were able to increase the soil carbon level in the last 30 years. So this is still possible. We know we have a lot of methods, management practices, also very innovative things we can do. So I'm still optimistic that we can maintain the level, or perhaps we can even increase the level. But you have to become active. You have to take care of your soils. You have to implement and soil carbon management, I would say.
Okay, thank you.
I totally agree with Martin. So there are so many possibilities farmers can do, but we need to differentiate between climate mitigation and carbon sequestration. So climate mitigation would be if we really have less carbon loss. So if instead of such a carbon loss, we have only such a carbon loss. That would be climate mitigation if we use as a reference this declining trend of agriculture, cropland, soil organic carbon that we observe in many parts of Europe. But carbon sequestration means net uptake of CO2 from the atmosphere. That means we need a net increase in soil carbon, and that is really a challenge.
Yeah. Okay, thank you. Axel Sauer, to give you the chance to have one more word. So what would you say, what would you recommend a farmer if he asks you he wants to enter a carbon farming initiative, and what shall he do?
Do you ask me or?
Thank you.
I ask you, Sauer,
okay.
at the moment.
I think me. Do you mean me?
Yes.
Yes. Sorry, Martin. I think yes. There's chance for the farmers. I think one of the first steps is also just to begin with the reduction of the emissions of the farm, of the works in the farms. And in the second step, it's also possible to increase the soil organic carbon with the proper measures, like introduction of cover crops or undersum crops, or change from cropland to grassland. I think there is a possibilities, and one of the possibilities is to begin with the reduction of the emissions, because if we want to have the net carbon sequestration or net climate effect, we have also reduced the emissions in the farm.
Yeah. You say there are also other important sources influencing the climate heavily. So, okay, carbon is not all. And maybe also the others. So my personal view is that we do have to do all things to keep the soil carbon and to green agriculture and to produce additional biomass and integrate it in soil and reduce the fertilization as well, and even energy input. So, and that's a big challenge all farms will have in the next years. And we have to look at it in combination and even at whole farm level. You need new concepts and new systems to tackle these demands society and climate has. So we will have to change the systems completely if we really want to react on these questions. So, but maybe one final questions to Axel and Martin. Do you have any recommendation what farmers should do in the next time to say if they are asked to enter a carbon farming initiatives? Should they do? Should they hesitate, or should they do their own system? Should they use inspiration to change the system? Shall they sell the carbon dioxide they can bound in their farms? Axel, do you have a statement?
Yeah. So the carbon farming initiatives are good to get inspiration of what can be done in order to enhance soil organic carbon, and therefore it's good if farmers connect with them and learn what's possible. But it's in the end in their own interest to maintain and increase soil carbon. And I would, as a farmer, keep the freedom to and the flexibility to find own ways to maintain and soil carbon, and wouldn't sign contracts with carbon farming initiatives, because at the moment it seems that many of these companies, carbon farming companies, initiatives and startups, they make quite some money with this, but the farmer in the end has to pay in the first place for the all sampling and analysis stuff. So I'm not sure whether he will really profit from this in the end.
Okay, thank you. Martin, do you have a statement?
I fully agree. And I think every farmer has also other emissions, greenhouse gas emissions. And I would not sell, even if you are able to build up carbon, I would not sell that to a company, you know? So the question is, should we not rather use that plus and try to compensate the own emissions? I think this is what should be in the focus. Yeah.
Okay. Thank you. Okay, thank you for these statements and the clear presentations we had. So I think we all vote for a greener agriculture with more biomass and changed systems and protection of soil organic carbon and soil fertility. That's of high importance, and there are really measures we can take to get better in future and to care for our soils, and maybe even in connection with local initiatives, with a local network of initiatives for soil carbon that really will help and drive the topic and even drive carbon in soil to higher levels. But be careful in selling in outselling your resources. I think that's a clear hint we give from this workshop. Thank you to the speakers and to the audience. And I hope we had an interesting session today. Great. Thank you to all.
Thank you.
Yeah, thank you too.
Thank
Bye-bye.
you. Goodbye.